Everyone, again, it's absolutely Radin, and welcome to my second video about chemistry. As I say, chemistry in Persian or Iranian method, but in English. Just sorry because of the time of my videos, as you know or may not, the internet speed is very low, and it's very slow in Iran. And actually I should spend 2 hours trying with VPN and other applications to just upload a 14-minute video in my YouTube channel, so please excuse me if anything goes wrong. As you can remember, I was talking about the creation of the time and the creation of everything in the last video. I told you that the elements are different in type and in just number in all of the places of the universe. But what is the problem with this difference? Why are they important for me? It's a difference, but the important point is that this difference in the number and type of the elements in different parts of the world just suggests us a theory of the beginning of the time, which we called it Big Bang. Actually, a Big Bang, a big explosion that creates everything in our world. Actually, if you want to believe that we have just 1 million extra words, you can't call Big Bang the beginning of everything. We can also say the beginning of our world and everything which we can see around us. But what was before Big Bang? As I say before, our scientists and our book methods try not to speak about the second of the Big Bang and absolutely about before of the Big Bang. They just try to speak about the developments or actually the improvement of creation, not just the first second. Why? I don't want to be curious actually. But what was Big Bang? I'm going to tell you. At the first second of the Big Bang, it was everything, but it was nothing. All the world, all the matter, and all the energy we know today were in just a very small, very hot and dense point. Actually, it should be dense because of the mass in very small volume actually. But it's very hot because of density. And just 1 second after that, that was a big explosion, which all of this hot, dense mass and energy just be explode, and this explosion threw that all over the space. Mass, lights, photons, and everything we know today in our world were made because of the Big Bang. At the Big Bang, a large amount of energy has been released. It just exploded a large amount of energy, which after less than 1 second creates the matter. The subatomic particles such as electron, proton, neutron, and some other kind of matters, which I'm not going to speak because they're not in our grade actually. It's soon to talk about them. As I say, it creates the subatomic particles such as electron, proton, and neutron. And just after that, the first elements such as hydrogen and helium, they were made of these subatomic particles, as I say, electron, proton, and neutron. But why hydrogen and helium? Because they were very light actually. They were not heavy. And just because of their weight, they were the two first elements. After that, as the time go on, as I say, the Big Bang was the beginning of the time. As the time go on and the hot, dense point, as you can remember, the temperature just decreased. and now we don't have that much of density. And after the temperature just decreased, then hydrogen and helium condensed and just compressed and make a huge compressed amount of gas, which we called it nebular. And these nebulars, as the time goes on, they create galaxies and stars. But the stars, I wanna stop at the stars station and talk about them a lot. Why stars? Stars are the factory of matter and elements. Actually heavy elements which are heavier than hydrogen and helium, because they were the first elements and their factory was originally the Big Bang. The factory of other elements are originally Big Bang, but they're not directly made of Big Bang. They're made of some functions in the stars. So we call the stars the factories of other heavier elements, such as carbon, lithium, and go on. But stars are a bit like human. They have a birthday, they will develop, improve, and grow up, and they will die. But a bit different. Why? Because their death contains a very, very huge explosion of matter and energy. And this explosion make the matters to just be scattered, or as I say, dispersed in the space. This big explosion threw all of the elements and all of the pieces of matter into the space. So the matter or the elements in the star will be scattered or dispersed because of the explosion, which contains the death of the star. But why? Why stars contain some elements which they will be scattered when it die? Why stars are the factory of elements? Because of their very, very hot temperature. They have some nuclear reactions or some nuclear functions in them. In all of the stars, even the small ones, such as Sun in our solar system, we have nuclear reactions and nuclear functions. In these nuclear functions, just light elements join together and they will make a heavier or bigger atom or elements. But everything will not always be okay. They will release a large amount of energy because all of these small and light elements are a bit heavier than the heavy atom if you just think them all. For example, we have, it's just an example. For example, we have two small atoms with 2 kilogram and 2 kilogram. They will join together and will make a bigger and actually heavier atom in 3 kilogram. 1 kilogram will be extra, and this kilogram of mass will become energy. So now, as I said before, we will need a formula for the connection between mass and energy. So, sorry for some influency in these minutes, actually. It's because of my medium English. As I say, in the stars, because of the very hot temperature, we will have nuclear reactions, nuclear functions. In that functions, light elements, small atoms just join together and they will make a big or a bigger atom or bigger elements or heavier elements. But some of the mass will be extra. As I say, a 2 kilogram and the 2 kilogram atom will join together and they will make a 3 kilogram atom as the results. 1 kilogram will be extra and it changes to energy. How? E equals mc squared. That's the formula which you can change the mass to the energy. If two atoms with 2 kilogram mass will join together and make an atom with 3 kilogram, 1 kilogram will be extra, and it will be changed to energy with E equals mc squared. C is the speed of light, as you know, and just if you have a matter and you will know the mass of your matter, and then if you just have the speed of light, you can calculate that how much of energy you will have. So stars will change the extra mass to the energy, and that energy is the light and the heat which we see from the sun, which we see in the sun. For example, the sun shines and the sun actually give us heat, and it has very, very high temperature. Why? Because it changed the extra mass, or the extra actually kilograms, to the energy with E equals mc squared. We will talk a lot about E equals mc squared. For example, the mass should be in kilogram, and what about the speed light, the light and its speed in different places, and we will completely talk about the function which change the mass to the energy. So if you are curious about E equals mc squared or Einstein's formula, I really suggest you to watch my third video. I hope you all enjoy and really learned something. Just excuse me if it was any problem. You're welcome to comment, subscribe, and like if you want. I will be very happy if I can improve the level of education with your comments. I will read them all. Love you, and just take care.